All right, welcome everyone to this AI 101 Explainer Masterclass. I'm absolutely thrilled you're here today. So grab a seat, get comfortable, because we are about to completely demystify the absolute alphabet soup of artificial intelligence. I mean, if you've been trying to keep up with tech lately, you know exactly what I'm talking about, right? It feels like a new acronym drops literally every single day. But hey, don't worry, we're going to break it all down together.
Now, if you've ever felt kind of intimidated or just straight up confused by buzzwords like ML, NNs, or Gen AI, look, I promise you, you are not alone. It can feel like a totally vertical learning curve. But here's the secret sauce. Instead of trying to memorize a bunch of random disconnected terms, we're going to build a really clear, relatable mental model today. And to do that, we're actually going to borrow a classic blueprint from computer science, the good old 7-layer OSI networking framework, to map out the entire evolution of AI. It's going to make so much sense.
So think of this OSI parallel as basically our course syllabus for today's explainer. We're going to build this sort of technological layer cake, starting from the absolute basic deterministic logic all the way up to human-level application. And the cool part, each AI concept maps beautifully to an OSI counterpart. We'll start at classical AI, which acts as our physical layer, and move all the way up to artificial general intelligence, or AGI, which is going to function as our application layer.
Okay, let's just quickly look at the agenda so you know where we're headed. 1. The foundation, classical AI. 2. The link, machine learning. 3. Routing and transport, neural networks and deep learning. 4. The dialogue, generative AI. 5. Taking action, agentic AI. And 6. The ultimate goal, AGI. All right, let's dive right in.
Starting right at layer 1, the foundation, classical AI. This is the absolute bedrock, where we basically pour the concrete for our whole AI building. Just like the OSI physical layer handles the reliable transmission of raw electrical signals, classical AI relies entirely on pure foundational rules and deterministic logic. It is strict, it's reliable, and honestly, there is absolutely zero room for adaptation here. You write the rule, and the machine follows it, exactly as written. No exceptions.
So why does this matter for your work? Well, if you're building a project that demands 100% reliable, unchanging logic without any guessing whatsoever, say a simple decision tree or an expert system where the rules are totally explicit, this foundational layer is exactly where your project lives. It's perfect for non-adaptive, strictly governed tasks. But, well, as we all know, reality doesn't always play by strict rules, right?
Which brings us perfectly to layer 2, the link, machine learning. Like I said, pure rules completely fail when reality gets messy. And what's really fascinating here is the stark contrast between these two approaches. On the left side, classical AI is super rigid. But on the right, machine learning acts as our OSI data link layer. Now in networking, the data link layer ensures reliable communication over an unreliable physical medium. Similarly, machine learning steps in to learn statistical patterns. It handles noisy, messy, real-world data where strict rules would just completely fall apart. So practically speaking, if your current project involves making sense of messy, variable input, you are effectively using machine learning to make the link reliable. You're moving beyond rigid rules into statistical pattern detection. And this is absolutely critical for tasks like classification, figuring out if an email is spam, or regression, like predicting future sales based on past historical data. Moving right along to layers 3 and 4, routing and transport, neural networks and deep learning. Okay, so this is where our architecture gets its actual plumbing and electrical routing. First up, neural networks act as the network layer. They introduce these interconnected nodes that route and transform information across a graph of connections, basically finding the most efficient path through the data. Then, deep learning steps up as the transport layer. By stacking these layers on top of each other, it handles segmentation, flow control, and even recovery from failures to ensure the end-to-end delivery of incredibly complex representations. And this right here shows exactly why deep learning is just so immensely powerful. Because of that insane depth, we can ensure that intricate data is interpreted completely and reliably. If you're working with massive, large-scale data, we're talking high-resolution images or vast bodies of text, you are firmly operating in the deep learning layer to get that highly reliable transport of complex features. All right, climbing up to layer 5, the dialogue. Generative AI. Now we enter the interior design phase of our layer cake. This is where the AI actually starts talking back to us. Generative AI parallels the OSI session layer.
Think about what a session actually is in networking, right? It manages state and connection across multiple turns. Well, that is exactly what Gen AI does for us. It maintains a coherent context and an ongoing dialogue. It ensures that whatever output is generated stays consistent, stays meaningful, and stays totally on topic throughout an entire conversation or creative process.
And why is this a game changer for your work? Think about it. Anytime your AI tool remembers what was said, say, 5 prompts ago, in order to write a perfectly consistent block of code, or to iterate on a generated image based on a whole history of previous inputs, that's Layer 5 at work. It is all about maintaining that absolutely vital context.
Which leads us to Layer 6, taking action, Agentic AI. Because listen, talking just isn't enough anymore. Eventually, the system has to actually do something. We can define Agentic AI by contrasting it with the OSI presentation layer. In standard networking, the presentation layer prepares data for the user. But Agentic AI, it flips that slightly. It prepares concrete actions for the real-world environment. It actually translates internal representations into actionable formats, and it structures goals to execute full-blown multi-step workflows.
So when an AI moves beyond simply giving you a recipe for a cake to actually calling an API to order the groceries for you, boom, it is crossed into the Agentic AI layer. It's using tools, it's interfacing with APIs, and actively completing complex multi-step workflows in the actual environment. We're moving from just conversational to truly actionable.
And finally, Layer 7, the ultimate goal, AGI.
We have officially arrived at the roof of our architectural stack. This directly mirrors the OSI application layer. In networking, the application layer is that final, seamless interface that you, the end user, interact with directly. Well, artificial general intelligence, or AGI, represents that exact same concept for AI. It's the ultimate user-facing general-purpose capability. It literally captures the aspirational future of all computer science.
And this matters because, well, it's the finish line we are all sprinting toward. We're talking seamless human-level interaction that can operate across literally any task or domain. I actually like to joke in my classes that this is the general assistant expected to perfectly handle absolutely everything we throw at it. It's finishing the ultimate construction of our AI stack. To quote the material directly, AGI represents the ultimate user-facing general-purpose capability. And I think that just beautifully sums up where all of these layers inevitably lead. You know, from the rigid, concrete rules of classical AI at the very bottom, all the way up through machine learning, neural pathways, and intelligent agents, we are building toward this single, unified application layer. Which brings us to our final question for today's class. And it's something I want you to really think about. When AGI finally completes the stack and becomes that ultimate application layer, what will your role be in building, guiding, and utilizing it? All right. Thank you so much for joining me for this Explainer Masterclass. Keep learning, keep exploring, and I'll see you all next time.